Oh, thank you all. Oh, I'm touched. You guys are so kind. Thank you all. Wow, really, too much. Too much, everyone. Okay. Time to settle down. Time to settle down. Just kidding. All right, welcome all to math class today. So glad that you guys could make it. I'm not here, obviously. I'm Mr. Foat from the past. And so we are going to get started on the study guide that you guys have. If you don't have it in front of you, that's okay. Right now, you guys should have this being passed out all to you so that way we can work on it together. I'm going to allow for a second to just get all the papers shuffled and ready to go here. All right, so there may be papers still being passed out. That's perfectly okay. We're going to jump right in. You guys can catch up because you don't have to write anything today. You'll have it in front of you. So our goal today is to try to get through the study guide as much as we possibly can. There are 10 total questions on this study guide. There will be 10 total questions on your test. So what you're looking at right now is going to be what the test looks like. It's not the test. It doesn't have the same questions as the test, but it will be helpful. Not only will it be helpful, this will also be worth an additional 2 points on your test of extra credit. So super important that you guys complete this, finish it up, and then staple it to the back of the test tomorrow. Okay? Now, last thing I do want to tell you is that the test itself, I mentioned this before, is 10 questions long. There are 2 questions of extra credit, but the entire test is word problems. Okay? So please make sure that you guys are prepared for that. We should be fine, okay? Especially if we complete the study guide. And plus, if you complete it, you get the extra credit. Done deal. You guys should be good to go, okay? All right, so let's jump right in. This question says, for number 1, a truck driver drove 2,019 miles in 7 days. Find the average distance he drove each day. Round your answer to the nearest whole number. Okay, so the very first thing that we should recognize with this question is that the goal that we have is to find the average distance. Okay, the average distance of what? The average distance he drove each day. So what we're going to do is we are going to set up a bar model that represents our information right here. It tells me that I have a total of 2,019 miles. So I'll draw my bar model. This entire bar is going to be worth the total amount of miles that we have. So that's going to be 2,019 miles. It says that we drove that many in 7 days. So over here, we are going to cut our bar model into 7 separate boxes. All right? That was a bug. So now that we have all of our boxes put together here, we are going to go ahead and solve. This shows me that over the course of these 7 days, we are going to split up the total. So here's what we should do. We should take the total, 2,019, and then we are going to divide that by the amount of days that it took to drive that. It does tell us that we need to round our answer to the nearest whole number. Okay, so we'll get there in just a second. When I go ahead and I divide this, 7 goes into 2, 0 times, you don't have to worry about that. So 7 goes into 20, 2 times. 14 is our answer there. When we subtract that, we get 6. We drop down our 1. So 7 goes into 61, 8 total times, giving us 56. 61 minus 56 is 5. We drop down our 9. We end up getting 59. So 7 goes into 59. Again, 8 times. We get 56 again. Okay, I'm just going to bring it up over here. So 59 minus 56 gives us 3. Now, what we're going to do is we're going to make a decimal point with a 0 and drop that down. So we end up getting what's acting as 30. Whenever we divide with a decimal point, we bring that decimal point straight up. So the next thing that we have here is 7 going into 30, which ends up being 4. All right, we don't have to continue to divide, even though this is not something that is completely solved yet, because we know that we are rounding. When it says to round to the nearest whole number, we know that we're working with everything to the left of the decimal point. So you'll see up here your answer. This is what we're considering. However, since we need to round, we need to go one place further, which is our 10th place right here, this number 4. This is going to tell us if we're going to round or not. If the number is 4 or below, we don't consider that number. It stays the same. But if that number is 5 or above, then we do. Sorry, the light's in my eyes. Then we do round that up, okay? So I'm going to step out of direct light here. Okay, so this ends up being something we don't consider. It's 4 or less. So our final answer here is 288 miles per day on average. So 288 miles per day. Okay, we should have that written down there. That was a question that goes over solving for the average of something. The way that you do that is you divide the total by the total amount that you're measuring by, so days, hours, minutes, whatever, and then you're going to find the average per the amount you are measuring by. Okay? All right, let's move on to the next one. So the next question that we are working through is going to be this one. I'm going to try to get it so that there's no glare. All right. And just see we can all read it together. Okay. Trying my best on this one, but we'll see. So number 2 says Sarah gets paid $8 per hour plus tips working as a waitress at a restaurant. On Tuesday, she worked 6 hours and made a total of $168. How much did she make in tips? Here's what we're going to do, okay? This problem tells me that we get 8 per hour. And how many hours do we have? 6 hours. So I'm going to draw my bar model. My bar model here is going to have 6 different parts to represent each hour. Okay? Inside of each box, I know that it's going to be worth 8, right? And that's consistent for every box after. Here's the next part. It says that she also had this, plus tips. And we need to figure out how much that is. So we're going to add on the end of our bar model here, this little box. We don't really know what this is. We're just going to write tips, because that represents how much the tips are. It then tells us that she made a total of $168. So over all of this, we know that it is worth $168. Okay? We should have this copied down the exact same way. So once we do this, we're going to be able to take 8 and realize that 8 times 6 is going to give us how much you made in an hour. 8 times 6, I'm going to give you guys just a second to write that down, equals $48 total that she made here. Okay, so we know that this section of our bar model, let's kind of draw a little arrow there, is worth $48. Well, now we need to figure out a way to solve. So if we look, 168 is all of it, and this part is $48. To find the tips portion, what we're going to do is we're going to take the total, 168. I'm like writing directly in the glare. Fantastic. Okay, we are going to take the total, 168, and we're going to subtract 48 from that. All right, I'm going to go ahead and I'm going to do that now. 8 minus 8 is 0. 6 minus 4 is 2. 1 minus nothing is 1. That tells me that that night she made $120 in tips. Wow, that is a ton of money to make in tips. But that's our answer for number 2. This problem, what we had to be able to do was we had to read it carefully. we had to make sure that we figured out, okay, if she makes $8 per hour, we can find how much she made per hour, subtract that from the total to find what's left. Okay? Always remember on problems like that we really want to be careful what we're multiplying and then what we use to subtract. All right? Okay. Next question. Here we go. Just going to go ahead, get started. So, this one says, it took Jeannie 6 hours in her car to travel 450 kilometers. What is her average speed in kilometers per hour? So, this one, what we're going to do is we are going to see, all right, we've got 450 total kilometers. It took us 6 hours to drive there. Our bar model is going to look like this. We're going to have a line straight across, 2, 3, 4, 5, 6, and that's going to represent how many hours that we drove. Now, it tells us the total that we went in distance, and that's 450 kilometers. To find the average kilometers per hour, we are going to have to divide the total distance by the total hours. Because what we're solving for is we're trying to make sure that we know how much one of these boxes is worth. So what we do is we take the total, 450. We divide that by 6. All right? So 6 goes into 45 7 times. We get 42. When we subtract 42 from 45, we get 3. And we drop our 0 down here. 6 goes into 30 5 times evenly. Okay, so we can do that. So we end up with the average speed of 75 kilometers per hour. Okay? Keep in mind, tomorrow on the test, if we don't have the unit of measurement here, I'm going to mark those as half credit, even if we get the right answer. Okay, if we don't get the right answer, it's just wrong. Okay, the unit of measurement is really important. So please make sure that you guys are staying on track with that and writing it. If it says kilometers per hour, this has to be kilometers per hour. Okay, that's really, really pivotal. Okay, all righty. Next one. We are just flying through. Man, you guys are doing a great job. Okay, keep up the good work. So, we are going to get into number 4. I think you guys can read that. Can you guys read that? Kids from the future? I hope so. Else this will be a long 45 minutes now, won't it? Okay, so number 4. How long will it take for a train to travel 234 miles at an average speed of 52 miles per hour? Well, this one we're going to have to visualize a little bit. It's a little bit harder, bigger numbers, more complex, but here's what we're going to do. Okay, we're going to make a bar model that shows us that the total amount of miles that we have is 234. Okay? Now, this is what we have to wrap our brains around, is that we have to figure out how many hours at an average speed of 52 miles per hour will it take for us to drive this. So what we're going to have to do is we're going to have to take this total and we're going to have to divide it by our average speed. Okay, and that makes sense, right? We talked about how if you've got a rate, so in this case, a rate of speed, you've got values per units. And so if you have perhaps, like in this case, we have the value, which is the amount of miles, but we don't have the units. What we have to do is we have to divide the value by the average to get the units. Okay? Whatever we're missing, we have to use what we have to find. So I'm going to set up a division problem here. 234 divided by 52. If you're anything like me, multiples of 52 can be a little tricky. So here's what we're going to do is we're going to estimate using the closest possible thing. 50 makes sense, and most of us can do that in our head. So let's do that. Let's do that together, okay? 50, 100, 150, 200, 250. So 250, too big, right? That was 5 times. So we probably want to try 4. Off to the side, what I want you guys to do is multiply 52 times 4. 4 times 2 is 8. 4 times 5 is 20. We end up with 208. Just to check, I'm also going to multiply it by 5. So 52 times 5. 5 times 2 is 10. 5 times 5 is 25 plus 1, 26. Okay, so we know 260, too big, can't go into it. Instead, we're going to do 4. 4 goes into 234 evenly. So we subtract 208 from that. When I subtract 208 from that, I'm going to end up getting, well, let's do it. So we borrow 10. 14 minus 8 is 6. 2 minus 0 is 2. 2 minus 2 is nothing. Okay, so we have a 26. Well, in this case, we're not told to round, so we know the answer has to be exact, or at least we're supposed to solve until it is, right? So what we'll do is we'll make a decimal point. Whenever I make a decimal point, it goes straight up. Then we add our 0. The 0 comes down. We get 260. Well, wait a second. You guys were awesome, and you wrote 260 up here on the board, 52 times 5. So that's one of the advantages of writing your work out and showing your work, is sometimes you're able to look back at what you've already done and use that for an upcoming problem. So 52 times 5, 260, that fits perfectly. So that means that we don't have to do any more math here. We just know that that's 5. So now here's what we know, is that this ends up being 4.5. I wrote that in the glare. Man, this glare is killing me. All right, 4.5. Are we done? No, we're not, because we have to put the unit. And the units here are hours. Okay, so once we do that, then our problem is completely done. We are able to drive 234 miles in 4.5 hours at an average speed of 52 miles per hour. Okay, so again, more averages. That's a really important skill for you guys to know. If you don't remember the 3 steps of average or finding average, remember the first step is we add all the values. The second step is that we divide that by all the units. Then we add our unit of measurement. Okay, that is all in your notes. It should be ready to go. But if you need a little bit of extra help, you got it. Okay, perfect. Let's move on to number 4. Okay. Oh, we were just on number 4. What are we talking about? Number 5. You guys, my goodness, I'm going crazy. So, number 5, here's our question. It tells us this. Sherry has to walk 1 mile to the library. She has already walked 0.8 or 0.8 of a mile. What percent of the distance has she walked so far? Now, this relies on us remembering some of the things that we learned earlier in this week about finding percentages. Okay, because in this problem, we have to conceptualize that the total amount of distance that we have to walk is 1 mile. Okay, and if we've already walked 0.8 of a mile, some of us are going to be able to solve this in our heads, right? However, what I would like you to get in the habit of doing is, if you have a total, so we can label this 1 mile is our total, okay? And we have a decimal, we know because it is 1, but we'll still label it. We want to multiply the total by the decimal, and then we convert to a percent. This one's actually kind of easy, okay? Because we have 1 mile total. If I multiply that by 0.8, well, I get 0.8, okay? Simple as that. 1 times 8 is 8. I multiplied with one decimal place, so we move it from right to left. We get the same thing, right? But you guys know that because anytime we divide or multiply by 1, we get the same thing, okay? Or same value. I shouldn't say same thing. We get the same value, just different numbers. Okay, so what does this tell us? It tells us that we need to remember our place value. So if I've got a number in the tenths place, remember that this is like saying this number is something times 10%. So in this case, this would end up being 80%, okay? That one is pretty easy, but imagine if it's ended up being some type of other crazy number, okay? So imagine we've got something like 0.83. What we do is we would know that the 8 in the tenths place would be 80%, and the 3 in the hundredths place is 3%. A thing to remember is back, I think it was on Monday. Yeah, it was Monday. Oh, so long ago. Okay? When we talked about percent coming from the Latin percentum, right? That idea that we are comparing things to being per 100. And so what we want to do is we want to say, okay, this is 83 hundredths. So it must be 83 percentum percent, right? Good. All right, so the final answer for number 5 ends up being 80%. But we had a good talk, figuring out how much we can make a percent out of decimals. Good. It's good stuff. Okay. All right, this one's a little harder. So let's jump right in. Number 6. Okay, we want to go up. Okay. Peterson spent 1/8 of his money on a new coat. What percent of his money did he have left? So this is a problem where, first of all, we'll notice this. Peterson spent 1/8 of his money. Okay? If he's spending 1/8, we know that 100% of his money would be 8/8. Okay? Let's draw a bar model to show that. Over here, we're going to go ahead and draw this out, okay? Remember, in a bar model, every box is equal to each other, unless we specify differently. So, if he ends up spending 1/8 of his money, we can even color that in if we'd like, okay? This is 1/8. We can even say this is what he spent. We know that the rest is money that he saved, or the money he had left, okay? If we count that up, this is a fraction which is 7 out of 8. Right? Our bar model shows us that. You'll remember when we talked about how to find the percent of a fraction, the best way to do that, in my opinion, is we are going to divide what we have, which is 7, by the total amount of things, which is 8. Okay? Or in this case, the top of the fraction, the numerator, divided by the bottom of the fraction, the denominator. Let's set that up over here. You may be thinking to yourself, Mr. Fote, have you finally gone completely crazy? The answer is not yet. Because how can 8 go into 7? Well, let me tell you this. So, even though 8 does not evenly go into 7, what we're going to do is we are going to add a decimal point and a 0 to the right. This allows us to divide into the decimals of this number. Whenever I divide, the decimal point goes straight up. And that means that we are going to be able to solve and treat this as if this is 70. Okay? It's not really 70, it's 7.0. But we're going to go ahead and divide. 8 goes into that 8 times, and we end up getting what we'll treat as 64. We know it's 6.4, and we get 0.8, but it's okay, right? We subtract this, and we get 6. Now, when I'm dividing a decimal, I can continue to add zeros. So, to the right, Okay, because otherwise it'll change the answer. So we add a 0 to the right, we drop it down, and now we've got 60. 8 times 7 gives me 56. So this allows me to continue to divide. 60 minus 56 gives us 4. And we're going to continue this pattern for the zeros on the right. We drop it all the way down, add it, 8 goes into 40. You guessed it, 5 times. Okay? Now, how do we take a decimal and use that to make a percent? Good question. I'm glad you asked. You right there who's watching, you. Okay? All right? But here's what we're going to do. We're going to remember our place value. We talked a little bit about this last question, but this is going to be a really important one. Okay? The 8 is in the 10ths place. So a way that we can think about this is 0.8 is equal to 80%. Okay? Next number, I've got 0.07 or 7 in the 100ths place. Okay? So we would take that, 0.07, and we know that since this 7 is in the 100ths place, this is going to be 7%. Okay? This is the final and the hardest one, okay? Because what do we do with this 5 that's in the thousandths place? Let's take that third and final 5, bring it over, try to make sure you guys can still see. We know that this 5 is in the thousandths place. Okay? Think about it this way. We know that percent is percentum, per 100. And so, using our knowledge of place value and decimals, we know that as we move to the right, these numbers get smaller. That means that if we stop at the hundredths to show a percent, if we move past that to the thousandths, that number gets smaller, in which case we would have a decimal or a fraction of a percent. Interesting, right? Okay. So this one being in the thousandths place is 0.5 or 5/10 of a percent. And we talked about this when we did place value. Okay. 10 of something smaller is 1 of something larger. Okay. 1 of something larger is 10 of something smaller. As we move up and down in place values, we move up and down by powers of 10. So please make sure that when you guys do this, you're keeping a very, very careful track. Is this number in the 10ths place? Because that would be whatever that individual digit is times 10%. Okay, if this is in the 100ths place, it's just that number. Okay, if anything comes after, it's getting smaller and smaller and smaller. Okay, so we've got all these percent. 0.875 or 875 thousandths ends up being broken out to be 80%, 7%, 0.5%. When I combine all those things together, I end up getting 87.5%, which, by the way, is our answer for this question. Because originally, we were asked to solve how much these 7/8 were. We know that when we divide the top number of a fraction by the bottom number of a fraction, it's going to produce a decimal that ends up being the percent. So please make sure that you guys are super, super careful with these. We've done enough over 8s. You guys are probably sick of these, but we should be good to go. Okay? All right. So hope we all have this written down. Great, perfect. I'm going to go ahead and erase this. As I erase this, if you guys wouldn't mind, please turning ahead, going to number 7. We're going to solve that one together. All right. Last page. We made it. Okay, awesome. These are too small. Man, need to use bigger font, I think. Oh, that's too big. Okay, I think this is as good as it's going to get. Here we go. So, number 7. This is what it says. A sound system originally costs $412. Angie bought it on sale for 75% of its original cost. How much did she pay for the sound system? So, here's what we're going to do is we are going to first break this problem down. A sound system originally cost $412. That's our total. I want you guys to box that in, okay? Remember, we're always visualizing. We're trying to underline things, circle things, anything we can use to help us, okay? Let's label this the total. All right, next up. It says Angie bought it on sale. Good job, Angie. For 75% of its original cost. So I would recommend that we underlined 75% of its original cost because that'll be helpful in the future. How much did she pay for the sound system? Here's what we're going to do. We are going to first set up a bar model. Now, it tells me that the total cost of this thing was $412. However, Angie, as frugal as she is, was able to purchase this at 75% of the original cost. So our bar model could look a couple different ways. For those of us who know this right away, that 75% is equivalent to 3/4, what you can do is you can section off your bar model to be out of 4, right? Because we know that this would be the part that Angie paid, 3/4. Some of us don't know that, and that's okay. In which case, what we would do is we would just kind of guess. We would say about where would 75% be in this bar, and we're going to label the part that's bigger 75%. Okay? It doesn't have to be perfect. It doesn't have to be exact, just so you know what it is. So we know that this is 75%, and the total here is 412. Well, now what we can do is we're going to be able to take the 75%, convert it to a decimal, multiply our total, and get the answer. Okay? We did this in class the past few days, but just a refresher. Whenever you multiply a total of a number, so in this case, we're going to be multiplying 412. And when we multiply that by the decimal version, in this case, 75, the decimal version of a percent, what we're saying is we want to find what 75/100ths of this number is. Okay, that's a little bit different than when we normally multiply, because when we normally multiply, it's repeated addition. We're saying, I want to see how many times 8 is if I add it 8 times. Okay, so we could sit there and go 8, 16, 24, 32, keep going all the way up until 64. We do this because it's faster. Now, this concept of multiplication, getting you a number that is smaller, starts with the idea of recognizing 0.75 is less than 1, right? Because in this case, $412 equals 100%, which if we were to put 100% as a decimal, that would equal 1.00, right? Because we're saying we have one whole thing, right? In this case, we don't have one whole thing. We actually have 3/4 of one whole thing, or 75% of that thing. So when we multiply this, we're just seeing what 75/100ths of that number is, and it gives us our answer. Let's go ahead and let's multiply. So 5 times 2 is 10. 5 times 4 is 5. 5 times 1 is 5. 5 times 4 is 20. we're moving to a new place value. To indicate that, we put 0 here. 7 times 2 is 14. 7 times 1 is 7, plus 1 is 8. 7 times 4 is going to give us 28. So we'll show that. Okay? Your math should look just like mine. Now what we're going to do is we're going to add down our two columns. So 0 plus 0 gives us 0. 5 plus 4, that's 9. 0 plus 8, 8. 2 plus 8 gives us 10. So we put a 0 here, carry over the 1. 1 plus 2 gives us 3. Oh boy, that was a great 3. Now, this is a really important step that we need to remember from when we were multiplying decimals prior, is that every place that is a decimal place, that's how many places we move the decimal place over from the right. So in this case, we've got 2 places that are to the right of a decimal place that we're multiplying with. So we'll start over here. We're going to move it over 1, 2 places. Okay? Good. Okay, good. Sorry, I was confused by something for a second. So we have our final answer here, which ends up being $308.90. Okay? And this is 75% of $412. Hold on, that doesn't make any sense. I have my notes in front of me. Let's double check this. 5, 2, 10, this. Okay, we're good. I don't know. I was getting all freaked out, guys. And that's what it is. So awesome, cool. We're gonna go ahead and we are going to move on to the next question. Okay, so you'll see at the bottom here, number 8 says 42% of a number is 231. What is the number? For this one, what we are going to do is we are going to recognize, okay, there is a number out there somewhere in the universe, and if we were to mark off all of that number at 42%, 42% of whatever number this is worth 231. Okay? Now, what we have to do is, first of all, we have to use this information to find what 1% of this number is. Right? If we're able to find what 1% of this number is and multiply 1% by 100, that's going to allow us to be able to find the entire value of the number. So we're going to take our total here, and once we take our total, we are going to divide it by the percent to find what 1 is, right? Because if we have 42%, we divide our total number, which ends up being this, total of 42%, divided by 42, we'll find 1%. So over here on the side, we're going to do 231 divided by 42. Now, again, we may not necessarily know what 42 is off the top of our heads. So what we want to do is we want to kind of round. 40 is easier to work with. 40, 80, 120, 160, 200, 240. Okay, so 240 gives us like 6 times. That's a bit too much for what we're working with. So we're going to try to multiply 42 times 5 to see if we get somewhere close. Okay, so 5 times 2 is 10. 5 times 4 is 21. We get 210, and that works for us here. So we are going to go ahead. We are going to solve this. Okay, so when we subtract this, 231 minus 210, 1 minus 0 is 1, 3 minus 1 is 2. Great, we get 21. Now, oh, I'm going to have to put this up here, sorry. In case we get 5. Well, we have a problem. 42 does not go into 21. But what we can do is this. We can add our decimal point right here, drop our decimal point down, and then we are going to be able to get 210. Well, we already did the math for 210. It's right over here, right? 42 times 5 gives us 210. So we don't have to do the math again. We know this is 5.5 equals 1% of whatever this number is. Fantastic. If we find what 1% of our mystery number is, we're going to be able to solve for the entire thing. Okay? So, off to the side. Now, what we have to do is we have to take 5.5 and we are going to multiply that by 100. Okay? We learned this before, but a fast way of doing this is that every place value, or if we count up the zeros, as many zeros as we have, is as many times as we move our decimal place to the right. I guess for your guys' screen it would be this way. Okay? So we are going to go ahead and move it over. We find out that our mystery number is 550, but maybe that didn't make sense to us. So up here, I'm going to show what happens when we multiply it by 5.5, like this. 5 times 0 is 0, 5 times 0 is that, okay? 5 times 1 is 5. We add a 0 because we're at a new place value. 5 times 0 gives us 5 times 0 gives us 0. 5 times 0 gives us 0. 5 times 1 gives us 5. So what we are going to end up doing here, we are going to add all of these things up. Okay? And we end up with a total. Now, this is something to keep in mind, that when we're multiplying by this, then we are able to see, okay, we multiply, we used one decimal place when we multiplied, and so if we start over at the right and we move this over one space to show that, we end up with 550, which is our mystery number. Okay? So, we're running a little short on time here. So what I want you guys to do for the next minute or so is I want you to take a look at 9 and 10 on your own. I want you guys to try to figure out, how are we going to be able to solve each one of things? Give you a hint. Number 9, we're going to have to multiply the total by the percent. For number 10, we are going to have to figure out what 1% of something is and then multiply it by the percent that's given. All right? You guys, just so you know, test is coming up tomorrow. I want you all to be able to solve well for that. So make sure this is completed. Finish this for homework tonight. And then when you get here tomorrow, staple it to the bottom of the test, to the bottom, okay? And make sure that your name is on everything. Please make sure that that is the case. This is bothering me. Okay, I'm really sorry. This is not right. Okay, sorry. So 412. 0.75. I gotta do it again, okay? Sorry, just give me 1 second. Just humor me. It's 6! Ah! How could I get that wrong? Oh my gosh. Okay, so my goodness gracious. Here's what we did wrong. I'm sorry, that's why I kept pausing, is because I was just I didn't know why it just felt wrong. Okay, 5 times 2 is 10. Okay, so 0's right there. But then we add the 1 over. 5 times 1 is 5, plus 1 is 6. When you add 6 plus 4, this makes this not 9, it makes it 0. We carry over the 1. This ends up being 9. Oh, man, totally missed that one. Mr. Fote led you guys astray. Unbelievable. All right, well, so there you go. Number 7, everyone can make mistakes, including Mr. Fote. Final answer, 75% of that is 309. Thank you guys. Have a great day, and I will see you guys when I get back. Bye. If I can click it. Hold on. Here we go. All right. Bye for real.